Well, hello there. We finally made it. I was a bit irritated by YouTube complaining about the low quality of the stream. And yeah, so basically we are finally live. Welcome to the development stream for May 2019. And first of all, let me congratulate all of you for finally voting for Multimaths, which is a plugin that I've been rooting for since the beginning because it basically replaces a whole ton of other nodes that you can use. And let's just have a quick look at it. I didn't actually prepare anything, but yeah, we will get there. So let me just create a null here. Auto key to modify it, just keyframe it somehow. Add a second null and add as a modifier. This is 2019, a nodal motion modifier, just something really simple. And what I'm going to do here is get the item info. I think that should be possible. There you go. From the first null, and basically pipe in the position from one null to the other, so that my second null and the first null are essentially the same position, and the first one follows the second one. So far, so good. Now, the thing is that you want to modify that position. So, you could use one of the many math nodes in here. That's all of the scalar nodes, or all of the trigonometry nodes, or even the vector nodes in here. And most of these you will be able to simply replace with the math node. And I did actually rename it to XMaths, just because I like the pun. And yeah, we have so many multi-nodes now that I think it would be nice to have something different here for a change. So XMaths it is, at least for now, unless you come up with something that's a lot better than that. And yeah, as you can see, you have two scalar inputs, x and y, and two vector inputs, a and b. And if you look at the user interface, you can you have the controls here for x and y, or the controls for the a and b vector inputs. And you have a scalar output and a vector output. So basically what this does is, let me just connect the position to the vector A, which also disables it, as it should be, because it's connected here, and the vector output to position. And what you can do now is essentially assign a mathematical function to apply to that vector output. In this case, what I will do is I will, for example, multiply A by x, and the x value is just going to be 2. Yeah, John, I'm glad it's sorted as well. So essentially now, the second null that we have is going to take the positions of the first null multiplied by 2. And yep, this is my first null. And you see that the second null up here has the same position times 2. So that would be a super simple way to do it. And what's nice about this whole setup with the multimaths, and which is why I wanted to actually develop it, is the fact that you can just simply change the mathematical function. So you might not want to multiply by x by 2 in this case, but you might want to divide. So you just change the function here, and that's all you have to do. There's no rewiring, no re-rigging, no picking out a different node to insert there. It's all within the same node. You just change the function that you use here, and all of a sudden the second null follows the first one, but with all coordinates divided by 2 as opposed to multiplied by 2. And that's essentially the core of what the node does. Hello, Carm. No, we just started. We had some technical issues in the beginning, so I just showed like the first example. And yeah, that's essentially the core of it. You can use any kind of mathematical function that either takes scalars or vectors. I might not have all of them in here. There's a list on our documentation wiki. Let me just pull that up. Where is it? There we go. That's db&w tools. And that actually still has the old name. So basically these are the computations you can perform on the scalar output. It's a really cheap one, but yeah, it's nice. And these are the computations you can assign to the vector output. I suppose technically you could do both at the same time, but it's going to be tricky because there are certain scalar computations or outputs that would be scalar that actually take vector inputs. For example, you can compute the length of an input vector, and that means that the input is a vector, but the output is a scalar. The same is kind of true for vector output as well, because what I did right now is I just multiplied a vector by a scalar value, a times x. So you would actually use one vector and one scalar output, but the output would be a vector. And I just noticed that there's a couple of other mathematical functions in here that we might want to include as well. Yeah, so well, look, I can always do this if you prefer it. But yeah, we did finally get a new webcam because Dagmar was breaking down, and for the live development stream, I'll be using it. And Dagmar will be using it for the Q&A session. That's because that's where I go full screen anyhow on Google Hangout. All right, yeah, I get that. Okay, so that's essentially the core of it. What you can also do is, let me just add a super simple vector node that really does nothing. Just to make, where is it? There you go, vector constant. And yeah, 1, 2, and 3. And input or connect that to B. And my operation is going to be adding A, which is the position of the initial null of null 1. And I'm going to add 1, 2, and 3 to the components. So yeah, this is again my initial null, and this is the other one, and you will see that it kind of follows it, but with a offset. And the offset is constant. It's 1 on x, 2 on, what is it? 2 on y, and 3 on z. There we go. Now, for a plus, it doesn't make any difference, but let's just divide it, a divided by b. That gives you, is that a bug? Ah, that might actually be a bug. Yay, cool. I found a bug. This actually doesn't do anything, but it should. If I multiply, yeah, it does something. All right, now the interesting thing is, that some of those, I mean, if you, it doesn't make any difference if you multiply A by B or B by A, that's the same thing. But A divided by B is clearly different from B divided by A. So if you find out that you connected the wrong thing to A and the wrong thing to B, what you can always do is swap, and that will essentially turn A divided by B into something like B divided by A. And you can swap the A and B vector inputs as well as the X and Y scalar inputs. So basically, there is no need to switch out the nodes here if you want a different mathematical operation, but there's also no need to reconnect the inputs just if you find out that you connected the wrong vector to the wrong input. You can just swap those around. And yeah, the functions we have in here, the scalar function is normal mathematical functions. There's some trigonometry in here. There is an option to get just the fractional part of a scalar, which might be interesting, or just the integer part of a scalar that's without the fraction. And the normal trigonometry. Well, the interesting thing with maths is, I suppose that the more you need it, the more valuable it gets. But yeah, for something like 3D animation, I suppose if I had started coding 3D animation earlier, I would have probably enjoyed maths more, even though I have to admit that I did in general anyhow. Oh yeah, oh yeah. And yeah, there's only a few vector operations here. I'm actually thinking about adding some of the matrix math as well. Not quite sure if I should do that. But you have things like, not this one actually. Oh, not this one either. Yeah, but this one that kind of creates a matrix from 3 different inputs, and then you could multiply a vector by a matrix, which is that this one? No, I thought there was one that has a matrix input as well. Oh, no, there actually isn't. So, yeah, that's probably something I'm not sure if I'll add it or not. The thing is, lots of these, I mean, or not lots of these, but something as simple as just adding two values is something you are certainly going to use. Or subtracting or getting the length of a vector for some reason is certainly super useful. Let's see, what could I create here to kind of show off what it does. Let me think. I think I might be able to come up with something. All right. So my second null doesn't have any position here. Yeah, this could actually work. Now, let me just... Okay. Let's see. What I'm going to do now is, that should work, is take my second null, which is somewhere in limbo at the moment, and animate it to follow the first one, but from an origin to the position of the second one. So let's see. I'll just maximize this. Yeah, there we go. All right, what I first need is I want the position of the A vector to be a direction, which basically means that it's normalized. And just add now use one of mine, a variable scalar here, which can be animated. And actually, no, I'll do it the easy way. I'm going to animate this scalar value to start at 0, and then at frame 120, it's going to be at 1. That's super simple. And I will take the vector and multiply that by the scalar. So the output is the position of the null 1 multiplied by a value between 0 and 1. And I'll attach this here. And as you can see, what this does is when the scalar value is 0, then this position is used for this null, but with basically 0 weight. So the scalar value is essentially a weight. And as the scalar value approaches 1, the second null kind of gets closer and closer to the current position of the second null. And that gives you almost a kind of a follower effect that you can control. I mean, you can do that with motion options as well, but that's one way to use that, mathematically and using something like XMaths. And that is one simple application of what can actually be done. My scene editor position is producing an error. What scene editor? Yeah, so that is essentially what it does. I will be adding more mathematical functions. And then I think that's initially it. I mean, of course, one thing I've done here is I've added a scalar and added the envelope here. You can also just, do it within the node itself if you want to. From, take frame 0 and 0, and add a frame at 120 and actually make that 2. And you will see that it's actually now going to start at frame 0, reach the position of the null, and then overshoot. And since this is a proper envelope, you can also just, smooth the whole thing and create some motions that might be, tricky to do otherwise. And if I move this, then obviously the other null is going to move as well. Well, we do have the button. Well, the problem with the teapot is that it's very Max centric. So because they've been using it a lot, and I think Eagle in a Barrel actually disappeared from Lightwave. It's not a part of it anymore, unfortunately. So yeah, that's essentially what XMaths does. Of course, it does work in all the contexts, so you can use it for shading. And also one thing that is important is that the vector inputs, like all the vector inputs, are exactly the same as color inputs. So you can essentially use the same math to modify colors if you want to. That works just as well. And yeah, let me just think of another super contrived example. Let's just save this as, all right. And I'm going to do something similar to this, except in this case, I'll just change the position of my initial null from 0 to 1. There you go. And I'll actually give this one just a shape, a sphere, so you give a bit more to see, like this. And what we're going to do in this case is, and this is going to dig a little bit deeper into the other db&w tools. I'll take the, where is it? I don't even know where my own tools are. Ha! There you go, Channel Blender. That's the one I wanted. And basically I'm going to output a vector that will have y value, which is the elevation. Dependent and this is the fun part, on the sign of the x value. And that gives us something like this. And if I actually say, well, all right, I also want to keep the x value of the original null, then I now have something like this. And I can add a second XMaths node right after this, where I'm basically going to multiply the input by, let's make it 10. Wait, wrong. I want it the other way around. I take the x coordinate, multiply that by 2, and then use that as a base for the sine function here. And I should get something that's a bit funkier. Yeah. So basically, the y position is created by the sine function that's due to the x position. And of course, you could do that using the normal nodes as well. But what's nice about this is if I just decide, okay, wait, I actually don't want to use a sine function, but a cosine, which is essentially just the inverse, then you can do that. And if you look at this, it actually changes the position. I'm not sure if a tangent is really going, it's probably going to work. Except that a tangent is really, really odd and you wouldn't want to use it for something like this. But yeah, there you go. That's one thing you can do. And yeah, that's essentially all there is to it. One thing that's technically interesting is that when it comes to light wave nodes, it is essentially up to the node itself to determine which inputs are being evaluated. So one thing that I made sure of is that each of the mathematical functions actually only evaluates the inputs that it needs. And that can be important if you have accidentally something connected to, let's say, the b vector that takes a very long time to compute, but you're actually using a function that actually doesn't use the b vector. Then the node itself doesn't evaluate that either, including all the heavy computation that you might have connected to it. No, there is no imaginary numbers in there. That would also require a bit of a new data type. Oh, do you mean something like divisions by zero? Well, a division by zero should be caught. I've got code for that where it's relevant, which is basically something like, yeah, for example, a square root. You can't have a square root of zero. So basically, or a square root of a negative number, which would result in an imaginary number. And Lightwave doesn't support those. So in this case, it says, yeah, only if the input value is larger than zero does it actually compute the square root in this case. Or in case of a division, only if, and that is actually wrong, only if y is not equal to zero does it actually divide x by zero. So if y is zero, it doesn't actually compute any of that, and basically just returns zero, which isn't correct, but it's, yeah, not really wrong either. No, 3 is the magic number, at least according to Didasol. I can post a link later. And yeah, so basically this is what it does. If you see the code here, I mean, it doesn't really tell you much, but you can kind of see what I did here. I wrote, this is not native C code. These are like macros, and they make sure that in this case, if I need the x, since I need the x input here, then I make sure to only evaluate the x input as well, and that's in here for each one of the mathematical functions that I'm actually using. These are the normal scalar ones, and these are the vector ones. And that should actually work, but yeah, I'll have to see why that doesn't. Oh, that's why it doesn't. There you go. That's the previous bug with the vector division fixed. And it's also fairly easy to add new mathematical function if something that's missing kind of crops up. That should be there. And I suppose in this case I should also, in this case the length might be 0, so if the length is not equal to 0, then actually compute the length. Well, that's at least one potential bug fixed. Yeah, so that's essentially all there is. Do you have any questions, suggestions? I'm reading the chat, so is Dagmar. And yeah, let me just grab some coffee. Cheers. You're being awfully quiet in the chat. Seriously. I have to turn on my webcam for this. There we go. Let's see if you can read this. Yeah, you can. This is from the mid-80s. I still have those from school. And they're actually in the shelf behind me. I use those. Is it in the input node? Well, not in this one. I think I think it's the surface node, isn't it? Where you have those. Let me just check. Oh yeah, to local to world. Yeah. So I suppose what I could do is add matrix math as well. Um, the only question is if you would actually want something like a where is it? Actually, I can just filter this down to matrix, can't I? Um, yeah, this basically creates a matrix using these values. The question is if the XMaths user interface should also have, the same kind of tabs for an A and a B matrix, essentially, because, you would basically extend this and have X, Y as to the two scalar inputs, A and B as the two vector inputs, and then probably M and N as the two matrix inputs. Then you would have one matrix output, and then um, up here or down here a pop-up that would basically say, okay, matrix is equal to, which might be a direct matrix computation, but also the vector could be equal to a vector being multiplied by a matrix, which essentially gives you a transformation of a point in space by the matrix. But yeah, Lightwave is a bit inconsistent in that it has matrices in some places but not in others. That would actually mean it looks like you don't have any matrix calculations in native Lightwave anyhow. Uh, because you have the scalar, trigonometry, vector. Yeah, there is actually no native matrix computations. So it might actually make sense to add those in, because then it would add an option that you don't actually have at all. Yeah, I did A-level math and physics, actually applied math and algebra. Then again, it was the only choices I had. Yeah, so I will look into matrices. Um, the plan for now is maybe to send this out as is, as basically as a preview build by Monday. That will give me enough time to compile the macOS version as well. And the preview build will also contain a bug fix to the multi-switcher, which used to lose the inputs if you did a copy and paste of the node. That doesn't happen anymore. And then I can, spend the next week or some hours during the next week to add matrices as well, which shouldn't be too much to do. And probably toward the end of next week, by Thursday or so, send out another preview build that includes the matrices, so you can look at that before the Q&A. And I can also spend some more time to, build some use cases of where the XMaths node can be used. And if you have an even better suggestion for the name of the node, please, you're welcome to write it in the comments or on Discord. So yeah, as far as I'm concerned, that's it for today. Unless you have any more questions. Yeah, I had the idea of math matters and also math effect, which would make it even harder to pronounce. But I kind of do like the XMaths. Actually, I wasn't thinking of Xmas. I was thinking of the X-Men. So yeah. And please, it's the British maths with the S. Very important. Yes, exactly. All right. So thank you all for joining in. One small announcement for all the patrons. Um, I'm actually working on editing down all the live stream, all the development streams of the first 6 months on Patreon. It's still going to take a bit more time, but there's going to be like a small supercut released next week, which is, I suppose, a few highlights of all the streaming that we've done in the past half year. And I'm also thinking about taking the Q&A sessions that we've all recorded and the development streams and basically create a small video for each month that kind of recaps the plugin that was developed at that time. Because we're actually not producing dedicated videos to explain the plugins, but while looking through the footage, I found out that I was actually explaining most of the functionality in the live streams anyhow. So, I might as well just edit that together and, create short videos for each one of them. And yeah, that's it. So thanks for joining us. And we shall see you on Discord and on the Q&A session probably next Friday. And I hope that many of you are going to join us in the Hangouts. Oh, and also, very important, there it is. Thank you very much for supporting us. It means a lot to us. Thank you. Bye-bye and good night.